Hello everyone. Today we will learn if any signed hexadecimal value is given, maybe 0x3 or 0xa. How do you know if it's a positive or negative number? And let's assume we got to know positive negative, how exactly we'll find its decimal value. Okay, now let's see what is happening here. Okay, I'm assuming we are considering 4-bit data. Okay, so if it's a 4-bit data, how will you represent it, and how will you represent this one? Okay, now very first thing that we will check is the MSB bit. In the first case, MSB is actually 0, and in the second case MSB is actually equal to 1. Based on this, we will determine whether it's a positive number or a negative number. Okay, if in case MSB is 0, it's immediately considered as a positive number, and because of which, now if you check here 0011, this in decimal is nothing but plus 3. But what is the second case? Second case, we have the first value is actually 1. If the first value is 1, immediately you should know the answer is negative. We know the answer is negative now, but what is its actual value? How do we find it? We need to find 2's complement of this particular value. That is the answer you have to substitute here. How do you find 2's complement of any number? 1 0 1 0 if it's the given binary data. First you will find inversion of this. What is inversion? Wherever there is 1, write 0. Wherever there is 0, write 1. This is also called as 1's complement or inversion. Okay, you can use any terminology there. This answer is your 1's complement. Next, I'll add plus 1 to this. Okay, this entire thing, 1's complement plus 1, is called as 2's complement. And what is the answer you get here? 1 plus 1 is 0, 1, 1 and 0. What is this value? This in decimal is nothing but 6. So I'll write the answer as minus 6. So if you're considering a 4-bit data, you will always check the first bit, that is nothing but the MSB. Based on that, you will determine whether it is positive or it is negative, and then to actually find the data, if in case it's a positive number, no changes are to be done. Write the decimal value of this particular binary data. If in case the MSB is actually 1, you will have to find 2's complement of that data, which is nothing but 1's complement plus 1. What is 1's complement? We have to just invert or find its complement. Wherever there is 0, write, and wherever there is 1, write 0. Okay, that's 1's complement. When you add plus 1, whatever answer you get, that itself is the value you have to substitute here. Okay, let's take some other example. Okay, let's take an 8-bit value. Okay, so let this 8-bit value be 0x44. Okay, and second value I'm taking it as let's assume 88. Okay, so how will you find its actual decimal value? This is a signed hexadecimal value. First thing in every case, which makes it very easy, is converting it into binary. For each hexadecimal value, find its binary value. What is 4 in binary? It is 0 1 0 0. Okay, what is 88? It is 1 0 0 0. Okay, next what I will do is I'll check the MSB. In this case it is 0, in this case it is 1. Okay, if MSB is 0, immediately we should know this is a positive number, and if MSB is 1, we know it is a negative number. Okay, so this we don't have any doubt. Next to that, what we have to do is, now if it's a positive number, directly convert this into its decimal value. How will you do that? Just multiply by the powers of 2. based on its position. So if you consider here, how will we do that? 0, 1, 2. Okay, that is 1 into 2 to the power 2 plus 2 to the power 6 into 1. 2 to the power 6 is how much? 64 plus 4, you will get the answer as 68. So if you consider the second case, okay, what we have here is 88 and it is given in this way, and we already know it's a negative value. As soon as we know the answer is negative, we know we have to find the 2's complement of this particular value. How will we do that? First we have to find 1's complement and then add plus 1. So what is 1's complement of this? It is 0, 1, 1, 1, 0, 1, 1, 1. If you add plus 1 to this, what answer you will get? 0, 0, 0, 1, 1, 1, 1. Okay, this is the answer we get. And what exactly is this in your decimal? Okay, we have root to the power 3, 4, 5, 6. 2 to the power 3 plus 2 to the power 4 plus 2 to the power 5 plus 2 to the power 6. Okay, so what is this answer? It is nothing but 120. Okay, so what will be our final answer? Already we know it's a minus 120. Okay, some time back I considered a as a 4-bit value. Okay, but what if it's stored in the registers of the ARM, okay, that we have been working from some time. Okay, if it's a 32-bit register, how exactly a is stored? It's stored something like this. And what exactly is this in binary? In this case, is it a positive number or negative number? By checking the MSB, we know it's a positive value. And how do you find its actual decimal value? It is nothing but by multiplying this particular data by the powers of 2, and the what power of 2 should be multiplied depends upon its position. Okay, that is, here it is nothing but 2 to the power 1 plus 2 to the power 3. Why? 0, 1, 2, 3. Okay, wherever you find 1, multiply it by 2 to the power its position number, and this is nothing but plus 10. So if you notice here, if we are storing a as a 32-bit value in some registers, and if we know that this is a signed number, then its conversion will be nothing but 10. Okay, when exactly will we obtain a negative number? If the initial value here it is greater than or equal to 8. Fine. If we have some number like this, 1, 2, 3, 4, 5, 6, 7, 8. Now is this a positive or negative number? If you convert, you will get 1 and all next set of values are 0. Okay, so now how exactly are you finding its actual decimal value? Because it is 1 in the MSB, we already know it's a negative value. How will you find the next case? Next case is find its 1's complement, and after finding its 1's complement, add plus 1. What is its 1's complement? Except for first value, all others will be 1. This is the 1's complement. What will you get? Plus 1. It's our initial value only. Okay, which is nothing but 2 to the power 31. What is 2 to the power 31? this is nothing but, I'll just write it here because there is no space there. 214748364 okay, minus, this is the actual value of this signed hexadecimal number in decimal. Okay, so it's very important we know how many bit data we are considering. Based on how many bit data it is, we will get to know what is the MSB. Okay.